Hello everyone. In this video, we will be exploring topic of file system management in operating system. Now, we will break down key topics like file concepts, access methods, directory structures, protection, consistency, allocation methods, and free space management. Let's begin our journey into how the OS organizes and manages all our data efficiently. This presentation explores how operating system manages file storage, organization, and access. We will cover core concepts and mechanisms that keep our digital data secure and accessible. We will be going to cover contents like file concepts, directory structure, protection and consistency, allocation methods, and many more. Now, what is file? A file is a fundamental unit of logical storage managed by the operating system. It can hold various types of data like text, binary, multimedia, or executable code. Each file is associated with metadata. This includes name, the human readable identifier type like .txt, .exe, or .jpg, location, the physical disk address, size, both current and maximum, owner, and associated permissions. Files support operations such as create, open, close, read, write, append, delete, truncate, and etc. Internally, files are divided into logical records, which are then mapped to physical blocks on the disk. Moving on to the next slide, access methods. The way we access data inside a file depends on its structure and purpose. Operating system typically supports three access methods: sequential access, direct or random access, indexed access. Now, what is sequential access? This is the simplest. The data is proceeded in a linear order from beginning to the end. It is commonly used in text editors and audio video players. Now, direct and random access, this allow reading or writing at any location using bit offsets. It's essential for applications like database where fast lookup is needed. Third, indexed access. This method uses an index similar to a book's table of content that maps to the file blocks. It allows flexible and fast access, often used in a large system. Now, choosing the right method affects speed and resource usage. Now, what is directory structure? To manage the files efficiently, the OS organizes them using directory structure. A directory is a collection of file names and their attributes. Different structures offer different advantages, like single level directory, all files are in one folder, simple but not scalable. Two-level directory, each user gets a separate directory, better for multi-user system. Tree-structured directory, files are organized hierarchical in folders and subfolders like Windows or Linux. Acyclic graph directory allows shared file using links, ensuring no cycles. General graph directory enables complete flexibility but needs mechanism like garbage collection to avoid cycles and maintain consistencies. These structures help the OS in file searching, naming, and grouping. Now, our next topic is protecting our file system. Protection mechanism ensures that only authorized users and processes can access or modify files. The OS provides various levels of access control, including read, write, execute. Read allows viewing file content. Write allows permitting editing. Execute allows running executables. One key mechanism is the Access Control List or ACL, which defines permissions for each user or group. Some systems use simpler models like owner, group, and others with combination of RWX bits. Protection is crucial to prevent accidental or malicious data loss, especially in multi-user or network environment. Now, consistency in file system. File system consistency refers to maintaining the correct state of the file system even after crashes or power failure. Key strategies include journaling. All the file system changes are recorded in a log or journal before being applied. If the system crashes, it can replay the journal to restore the state. Atomic transaction. Updates to the file system are treated as an atomic action. They either complete entirely or didn't happen at all. Consistency checkers. Tools like FSCK in Unix can and repair inconsistencies in metadata and file structures. These mechanisms ensure that the file system remains reliable over time. File system structure. The file system is designed in a layered architecture to separate concern and enhance modularity. The main layer includes application layer, logical file system, file organization module, basic file system, and I/O control. Application layer, user level applications interact with file using system calls. Logical file system manages metadata, directory structure, and permissions. File organization module maps logical blocks to physical disk blocks. Basic file system issues command to read and write actual disk blocks. I/O control layer handles device drivers and hard level. How do we manage free space? Now, we will delve into the topic of free space management. When files are deleted or shrinks, space is freed up. The OS must track this space for reuse. Common strategies include bitmaps. Each bit represents a disk block, 1 for allocated and 0 for free. Easy to manage but managed memory. Free lists maintains a linked list of all free blocks. Grouping stores the addresses of multiple free blocks in the first free block. Counting keeps account of contiguous free blocks starting at allocation. Efficient for large free spaces. Proper free space management prevents wastage and fragmentation, ensuring the disk is used efficiently. We can conclude that file system management is one of the most critical part of an operating system. It defines how data is stored, accessed, protected, and organized. For simple file operations to complex consistencies and allocation mechanism, the file system ensures that we can rely on our computer to manage data efficiently and securely. Thank you for watching. If you found this video informative, feel free to like, subscribe, and leave your questions or thoughts in the comment.